In the 1950s, at the height of the Cold War, the United States Air Force undertook a project that seemed to come straight out of science fiction, an attempt to build a supersonic flying saucer. Codenamed Project 1794, this secret program aimed to develop a disc-shaped aircraft capable of vertical takeoff and landing, VTOL, and extreme speeds, intended to intercept Soviet bombers in the stratosphere. At the time, the Soviet Union was developing fleets of nuclear-armed long-range bombers, like the Tupolev Tu-95 Bear, capable of striking North America, so the U.S. and Canada were racing to deploy defenses. Radar warning lines across the Arctic, anti-aircraft missile sites, and high-speed interceptors were all part of that effort. A vertical launch, high-speed saucer that could spring up from hidden bases to ambush enemy bombers was an enticing concept amid this Cold War arms race. For decades, the details of this audacious venture remained hidden under top-secret classification. Only in recent years, with the declassification of Air Force archives in 2012, has the full story of America's experimental flying disc come to light. What those documents reveal is a fascinating tale of ingenuity, optimism, and ultimate disappointment, a chapter of aviation history where the line between imagination and reality blurred. Interestingly, even at the time, a few hints of this secret project reached the public. Popular Mechanics magazine noted in 1956 that the Air Force was working on a vertical rising, high-speed aircraft, and in 1960, it even published a photograph of a disc-shaped craft, presumably the Avrocar, without revealing its name or purpose. These brief publicity glimpses aside, the full truth of Project 1794 remained unknown until its files were opened decades later. Project 1794 was conceived in an era of nuclear tensions and rapid technological daring. The U.S. military was urgently searching for a new type of interceptor that could launch from makeshift airstrips, or even no airstrip at all, and climb quickly to shoot down Soviet long-range bombers. Traditional jet fighters required long runways, which might be destroyed in a surprise attack, so a vertical takeoff aircraft with high performance was an attractive, if extremely challenging, concept. At the same time, public fascination with flying saucers was at its peak. The idea of disc-shaped craft had captured imaginations due to a post-war wave of UFO sightings and science fiction films. In fact, the Air Force had its own official UFO inquiry programs, Project Sign in 1948, Grudge in 1949, and later Blue Book, investigating flying saucer reports, even as, behind closed doors, it was developing a real flying saucer of its own. Disc-shaped aircraft weren't entirely unheard of. The U.S. Navy's experimental, Vought XF-5U Flying Flapjack in the 1940s, for example, had a flat, round wing, but those earlier attempts were subsonic and conventional. Project 1794's vision of a supersonic jet-powered saucer was breaking new ground. In a twist of fate, the Air Force's cutting-edge interceptor project would end up adopting the iconic saucer shape, though for purely practical engineering reasons. For this unconventional program, the Air Force turned to an unlikely partner, Avrocar Canada, a premier aircraft manufacturer based in Ontario. The lead designer was a brilliant British-born engineer named John Jack Frost, who had come to Avro in 1947 after working on advanced jet projects in England. Frost was known for his unorthodox ideas. While at Avro, working on conventional aircraft like the CF-100 and the cutting-edge CF-105 Aero, he quietly began experimenting with novel aerodynamic concepts in a secretive special projects group that he led. Among his insights was the use of the Commandant effect, the tendency of airflow to adhere to curved surfaces, to create a cushion of air beneath a curved disc. If a jet engine's exhaust could be directed outward over a saucer-shaped body, Frost realized, it would generate lift by pushing air downward and forming a hovering cushion. This, he believed, could be the key to a truly vertical takeoff flying machine. Frost's imagination was also fueled by persistent rumors that had surfaced after World War II, claiming that Nazi engineers had developed flying disc aircraft in the war's final years. Though such stories were dubious, they were widely circulated in the 1950s and seemed plausible in light of Germany's leaps in rocket and jet technology during the conflict. Frost feared that if there was any truth to these reports, the Soviet Union might have seized that technology, and he was determined not to let the West fall behind in the race for a radical new form of flight. By the early 1950s, Frost had begun building prototype concepts in secrecy at Avro. Initially, his team, dubbed Project Y, explored a spade-shaped VTOL aircraft and tested small-scale models before eventually focusing on a fully circular planform by 1953. Working behind locked doors at Avro's Malton facility near Toronto, Frost's Special Projects Group constructed components without most of the company even knowing the project's true nature. One Avro workshop superintendent later recalled that the project was so secret, engineers manufacturing parts often didn't understand what they were for. Frost would sketch out a needed piece for the machinist and then immediately have the drawing destroyed once the part was made. Even as rumors spread among Avro employees that we were building a flying saucer, only those with direct clearance were allowed inside the secured shop to see the strange craft taking shape. As Frost refined his design, he sought support beyond Avro's limited Canadian budget. In 1953, the U.S. Air Force got wind of Avro's experiments and sent officers to observe the work in Malton. Impressed by the concept and eager not to let the Soviets gain any edge, the Air Force began providing funding. By 1955, Project Y had been formally adopted by the U.S. Department of Defense under the codename Weapon System 606A. Later also referred to as Project 1794 or even Project Silverbug in some circles, with American money pouring in, the effort accelerated and remained cloaked in even deeper secrecy. Avro's prototype saucer was soon painted with U.S. Air Force insignia as it became an official, though still classified, U.S. military program. Even as the U.S. joined the project, the Army's and Air Force's expectations for the craft began to diverge. The U.S. Army was interested in a subsonic, all-terrain flying platform for troops, while the Air Force still wanted a fast VTOL interceptor that could hover below enemy radar then zoom to supersonic speed. Avro's designers optimistically believed they could satisfy both services, but in reality, these two sets of requirements were too different to reconcile in a single design. Notably, small-scale wind tunnel tests conducted with models at Wright-Patterson AFB had already hinted at a serious limitation. The circular wing's ground effect cushion became unstable just a few feet above the surface. This implied the saucer would likely never reach high altitude or supersonic speeds as originally envisioned. Nevertheless, the project pressed on, aiming to determine whether a useful low-altitude craft could be developed for the Army's purposes. Under the U.S.-funded project, Frost produced a detailed proposal for a revolutionary aircraft. In 1956, he completed a 117-page Project 1794 development report, outlining a disc-shaped craft unlike anything the world had seen up to that time. The design called for a roughly circular airframe with a large central turbine, dubbed a turborotor, powered by no fewer than 6 turbojet engines embedded around the disc. This turborotor would suck in air from above and force it out through vent ducts around the rim of the saucer. By deflecting the exhaust downward along all edges of the disc, the craft would ride on its own ring of thrust, essentially a donut-shaped cushion of air, enabling it to hover vertically. Vanes and shutters along the circumference could vector this exhaust flow to stabilize the hover or to tilt the craft in any direction for forward flight. In theory, the flying saucer would have no defined front or tail. It could maneuver equally well in any direction, making it an incredibly agile platform if the concept worked as intended. Instead of conventional tail fins or flaps, control would be achieved by vectoring the thrust itself. The pilot's inputs moved specialized vanes to redirect airflow to different parts of the rim, allowing the saucer to pitch, roll, or yaw without the need for wings or a tail. It was a cutting-edge approach to flight control, essentially using jets of air as invisible control surfaces. One of the declassified schematics from Project 1794 shows a detailed cutaway of the proposed supersonic saucer. The design included a large central turbine rotor, the turborotor, driven by multiple jet engines, with ducts channeling the exhaust flow out around the disc's circumference. By venting thrust out along the rim, the craft would create a powerful cushion of air underneath it for vertical lift, and the pilot could redirect this thrust to propel the saucer forward or sideways as needed. In essence, the vehicle could hover like a helicopter but also promised the streamlining to transition into high speed flight at extreme altitudes. Engineers were excited by the disk's symmetry, theorizing that an aircraft shaped like a flying saucer could be maneuvered in any direction with equal ease, a truly omnidirectional interceptor. As ambitious as the basic concept was, the performance goals were even more astounding. Frost and his team projected that their saucer would be capable of reaching speeds between Mach 3 and Mach 4 on the order of 2,300 to 3,000 miles per hour, and soaring to altitudes above 100,000 feet. The range was to be about 1,000 nautical miles, allowing the craft to cover vast distances or patrol large areas without refueling. If achieved, those figures would have rivaled or exceeded the world's top jet fighters of that era, and even approached the performance of the era's rocket-like experimental planes. Essentially, Project 1794 envisioned a vehicle that could take off vertically like a helicopter, then accelerate to performance levels comparable to the fastest high-altitude aircraft, a truly radical hybrid of a flying saucer and a supersonic jet. The initial project plan estimated the development cost at roughly $3 million, around $26 million in today's dollars, a relatively modest sum for such a revolutionary endeavor, though in practice the costs would climb higher as development continued. By late 1956, Avro's design work had progressed far enough that the U.S. Air Force and U.S. Army agreed to jointly fund the construction of flying prototypes. Frost established a high-security workshop at Avro's Malton plant to actually build the saucers, with armed guards restricting access to only essential personnel. Even the president of Avro Canada required special clearance to enter the special projects area. One Avro employee recalled that very few people got in there. If you walked anywhere near, there were security guards keeping curious eyes away. American technical liaisons frequently visited to oversee progress as the U.S. military poured several more $1 million into the WEX effort over the next few years. Project 1794 truly epitomized Cold War secrecy, a cutting-edge aviation venture hidden behind closed doors and strict need-to-know protocols. Of course, such an extraordinary project did not escape the notice of adversaries. Declassified Soviet archives, notably the Matrokin papers, later revealed that the KGB had managed to insert a spy at the Avro facility, seeking information on advanced projects including the flying saucer and the Aerofighter. The Royal Canadian Mounted Police eventually discovered the mole's identity and foiled the operation, though the agent's name was never publicly disclosed. This real-life espionage underscored how seriously both sides of the Iron Curtain took any prospect of a technological breakthrough. While the Air Force's focus remained on a high-speed interceptor, the U.S. Army became equally enthusiastic about the project's potential. The Army was experimenting with all manner of flying jeep concepts, small VTOL craft for battlefield mobility, and saw Avro Saucer as a candidate for a futuristic hover vehicle to ferry troops or provide close air support. Frost himself began to imagine scaled-up versions of the disc. A colleague, Ken Palfrey, later said Frost was planning a saucer 4 times as big to move troops in and out of battle like helicopters do now, visualizing giant troop carrier flying discs that could lurk under enemy radar, drop soldiers into combat, then zip into the stratosphere before hostile forces could respond. Such ideas illustrate just how far the team hoped to push the technology if the smaller proof of concept succeeded. Earlier wind tunnel trials with scale models at Wright-Patterson, AFB, had hinted at potential stability problems. The cushion of air under a disc tended to become dangerously unsteady once the craft rose more than a few feet off the ground. This meant that achieving the Air Force's lofty goals, like true high-altitude flight or supersonic speed, would likely be impossible, though testing went ahead to see if a workable aircraft might still be made for the Army's lower altitude needs. By 1958, Avro had manufactured the first prototype vehicle, which the Army designated as the VZ-9 of Avrocar, with a V standing for Avro in the U.S. Army system for experimental VTOL aircraft. This prototype was about 18 feet, 5.5 meters, in diameter and roughly 3.5 feet thick, built largely of aluminum and stainless steel, and it implemented a scaled-down version of Frost's propulsion concept. Instead of 6 engines, the Avrocar had a single turborotor fan driven by 3 Continental J69 turbojet engines, each feeding its exhaust into the central rotor to spin it. The craft weighed around 5,000 pounds empty and rode on a tripod of small landing wheels, later replaced in testing by simple skid pads. 2 petite, bubble canopy cockpits were faired into the upper surface of the disc, giving it a distinctly saucer-like profile. The whole vehicle resembled a giant metallic frisbee, only about 3.5 feet tall at its center, which naturally invited comparisons to the flying saucers of science fiction. Photographs from the period show the Avrocar gleaming in bare metal, with its twin clear dome cockpits and spindly landing gear, looking every bit like a craft from an alien world. On paper, this smaller test craft was still expected to reach about 225 knots, 260 miles per hour, and 10,000 feet altitude, far less than the Mach 3 plus dream of the original proposal, but reasonable for a low-level flying Jeep concept. In reality even, those more modest figures would prove optimistic. In a dramatic twist, just as the saucer prototypes were coming together, Avro Canada was dealt a devastating blow. On February 20, 1959, remembered as Black Friday in Canadian aerospace history, the Canadian government suddenly canceled the Avro CF-105 Aero Interceptor program, which had been Avro's flagship project. Overnight, the company laid off thousands of employees, and Avro's future was thrown into uncertainty. Frost's secret saucer team was initially caught in this mass layoff, but within days many of the special projects engineers were rehired as the U.S. military intervened to keep the saucer program alive. The special projects group was moved into Avro's nearly empty main factory building, and work on the Avrocar continued, albeit under the shadow of the CLAS company's larger troubles. This turbulent episode underscored how precarious the project's existence was. Without the infusion of U.S. interest and funds, the flying disc might have been abandoned then and there. Later in 1959, with Avro's internal crisis weathered for the moment, attention turned back to making the saucer fly. The first free flight tests of the Avrocar began in late 1959 at Avro's Malton test site. Initial trials were conducted with the craft tethered to the ground by cables to prevent accidents while the engineers calibrated the controls. Once they felt confident, the team prepared for a full untethered flight. In November 1959, test pilot Władysław Spud Potocki, a former Polish Air Force aviator who had also tested the Aero, climbed into the Avrocar's left side cockpit for a historic attempt. The 3 jet engines were throttled up with a deafening scream, and the saucer's turborotor spun to life. Slowly, the 18-foot wide flying saucer lifted off the ground, hovering on a cushion of its own exhaust, and blasting a furious downdraft of air and snow outwards between the hangars. For a brief moment, it seemed that the stuff of science fiction had become reality. The disc was flying. However, sustaining controlled flight proved exceedingly difficult. As Potocki eased the Avrocar a bit higher beyond the ground effect cushion, the saucer began to wobble and pitch unpredictably. The instability grew rapidly. The craft started to oscillate in a motion the crew had seen before in tethered tests, a phenomenon they nicknamed hubcapping because it resembled a spinning hubcap wobbling on pavement. Potocki felt the vehicle lurching like a bucking bronco and immediately cut power, bringing the Avrocar back down after only a few seconds of free flight. The engineer's heart sank. The first untethered flight had ended almost as soon as it began, and it confirmed the saucer's tendency to become uncontrollable without the stabilizing cushion of air. Nevertheless, the Avro team pressed on. After the aborted flight, they went back to the drawing board and methodically set about trying to fix the problems. Day after day, engineers made incremental changes, then wheeled the craft out for another tethered hover or a cautious low hop. There were moments of progress, a bit more stability here or a slight increase in lift there, but the fundamental issues persisted. What had seemed straightforward in theory was proving stubbornly difficult in practice. The mood within the project shifted from the excitement of the early days to a more dogged determination. Frost and his colleagues were not ready to give up on their dream. They still believed that with enough ingenuity they could conquer the saucer's quirks. In the months that followed, the team conducted numerous test runs and continually modified the Avrocar in an effort to overcome its flaws. They experimented with reshaping the exhaust deflector nozzles, adding thin spoilers on the disc to disrupt troublesome airflow, and even attaching a flexible skirt around the edge of the vehicle to better trap the air cushion, essentially an early hovercraft-like approach. The Air Force suggested adding a tailplane or fin to improve stability, an idea that Frost flatly refused. He wouldn't have it. When the Americans suggested that, it was about the only time I ever saw him angry, Palfrey recalled of Frost's reaction. Nevertheless, a small makeshift tail was tried, along with adjustments to the control vanes and other tweaks, but nothing cured the fundamental instability. The Avrocar could hover close to the ground, but as soon as it rose more than about 3 feet, it would start to tilt and gyrate dangerously. And while it could scoot along in ground effect, it never achieved speeds above roughly 30 knots, 35 miles per hour, in those low hover tests. In short, the vehicle fell woefully short of its design requirements. It lacked the stability and lift to transition out of ground effect, let alone approach jet-like speeds. One major issue was that the saucer's novel propulsion system was bleeding away thrust. Although the 3 jet engines provided an impressive total of about 5,000 pounds of thrust, the way that force was distributed around the rim led to significant losses in pressure and efficiency. The air pushed through the circular plenum lost energy to friction and turbulence, meaning much of the power never translated into useful lift or thrust for the aircraft. As Air Force historian Jeff Underwood explained, they didn't understand the fluid dynamics. All the thrust was being bled off by the ducting and airflow path. In essence, the Avrocar's engines were working hard, but the craft wasn't getting the full benefit, a critical shortfall for a vehicle that needed every pound of lift it could get. Another issue was the lack of advanced flight controls. The saucer was inherently unstable by its aerodynamic nature. Later analysis showed that its center of pressure in forward flight lay well ahead of its center of gravity, a recipe for constant pitching and stability. Frost's team had built a mechanical stabilization system that they hoped would help. The spinning turborotor itself acted as a gyroscope, and a series of automatic dampers and feedback linkages were supposed to detect and counteract sudden tilts of the craft. But these mechanisms were relatively slow and imprecise. Once the Avrocar started oscillating, the pilot had little hope of manually correcting it in time, and the automated controls couldn't react fast enough either. Decades later, experts noted that what the Avrocar really needed was a computerized fly-by-wire system to stabilize it, technology that, in the 1950s, simply didn't exist in practical form. Ironically, the Avro Aero had been pioneering rudimentary electronic stability control, but those advances were not applied to the saucer. Frost was essentially trying to be a very exotic aircraft with nothing but analog controls and human reflexes, and it wasn't enough. By 1961, after several years of testing and tinkering, it was evident that Project 1794's flying saucer would not meet its objectives. Interest within the U.S. Air Force had waned, and the Army, which once imagined replacing helicopters with saucers, had also moved on to more conventional VTOL designs. Formal evaluations in 1960 and 1961 confirmed the Avrocar's performance limitations. When flown without tethers, it was unstable and could reach a top speed of only about 35 miles per hour. In light of this, the Pentagon decided to pull the plug. Project 1794 was officially canceled by the end of 1961, and all funding was cut off. In total, the U.S. Department of Defense had spent roughly $7.5 million on the program by that point, equivalent to tens of millions in today's money. The highly classified venture that began with the hope of a game-changing interceptor ended quietly, its results deemed unsatisfactory and its remaining documentation filed away in secret archives. For Avro Canada, the end of the saucer program was a final setback from which the company never recovered. Avro struggled on for a few more years with smaller projects and subcontracting work, but it never regained its former stature and ultimately ceased operations by 1965. As for Jack Frost, the visionary behind the project, he left Avro shortly after the cancellation. Colleagues say he was completely fed up and disheartened by the project's demise, and he soon immigrated from Canada in search of new opportunities. He eventually settled in New Zealand, where he continued to innovate, working on various aerospace and engineering ideas, even collaborating with students on human-powered flight. But he never again had a platform like Project 1794 to showcase his bold concepts. One poignant footnote: Frost believed that the Avrocar's use of an air cushion was essentially the same principle later used by the hovercraft, and he felt he never got proper recognition for that contribution. In his final interviews, he complained that he had been robbed of credit for inventing the hovercraft, distinction generally given to Britain's Sir Christopher Cockerell in 1959. Indeed, observers noted that Frost might have found success had he refocused the Avrocar as a ground-effect hovercraft. But his eyes were set on the skies, and that opportunity passed by. In May 1979, just after retiring, Frost died of a heart attack at age 63. Spud Potocki, the test pilot, moved to the United States and worked as a pilot for North American Rockwell before retiring. He passed away in 1996 at age 77. What became of the flying saucers themselves? The two Avrocar prototypes built under Project 1794 were retained by the U.S. military after the project's termination. One was kept by the U.S. Army, which stored the disassembled craft in crates at an Army depot. It was later transferred to the U.S. Army Transportation Museum at Fort Eustis, Virginia, and as of today it remains there in unassembled storage. The other prototype was claimed by the U.S. Air Force and eventually ended up in the Smithsonian National Air and Space Museum storage hangars in Maryland. There the saucer sat, for decades, away from public view, an odd relic of a secret era, gathering dust under canvas. In 2007, the Air Force decided to bring this piece of history out of the shadows. The Smithsonian's Avrocar was loaned to the National Museum of the U.S. Air Force in Dayton, Ohio, where a restoration team began painstakingly cleaning and reassembling the corroded machine. They repaired components, fabricated missing parts, including new plexiglass bubble canopies for the cockpits, and restored the Gort saucer as much as possible to its original condition. One of the original Avrocar prototype flying saucers now sits on public display at the National Museum of the United States Air Force in Dayton, Ohio. After the project's cancellation, the two disc-shaped craft, built by Avro Canada, were kept in U.S. custody. For decades, one prototype remained in storage, while the other eventually made its way into the Air Force's museum collection, where it was fully restored in the late 2000s. Today, museum visitors can walk up to the shiny aluminum saucer, complete with its twin bubble cockpit domes, and marvel at this curious Cold War relic. Informational placards beside it explain how this experimental vehicle was meant to be both a hovering flying platform and a supersonic interceptor, encapsulating the daring dreams and daunting challenges of its era. The Avrocar's legacy, though tied to a technical failure, still left its mark on aerospace innovation. The project yielded valuable data on vertical thrust and vector propulsion that informed later designs. In fact, while Avro's saucer was struggling, other engineers were pursuing alternate VTOL solutions. A French designer named Michel Wibault proposed a system of redirected jet thrust that directly influenced the British Hawker Harrier jump jet, the first operational vertical takeoff jet fighter. The Harrier, introduced in the 1960s, achieved what the Avrocar could not by using rotating nozzles on a boss. More conventional airframe, proving far more stable and practical than a disc platform. The general concept of vectoring engine exhaust, however, lived on. Today's advanced aircraft routinely employ thrust vectoring. The F-35B Lightning II, for example, can swivel its main engine nozzle downward to hovering on top of the line. Fighters like the F-22 Raptor use vectored thrust to perform maneuvers that conventional jets cannot. These technologies owe something to the early trial and error efforts of projects like 1794, which showed both the potential and the pitfalls of pushing the flight envelope in unconventional ways. After remaining classified for half a century, Project 1794's story finally emerged. The Air Force declassified the program's documents in 2001, and the National Archives approved them for public release in 2012. Historians, aviation buffs, and curious readers could at last pore over the blueprints, test reports, and photos, gaining a full appreciation of this unique Cold War endeavor. Today, with the benefit of hindsight and those declassified records, Project 1794 stands as a fascinating, if little-known, chapter in aviation history. It was a bold venture born of its time, those nervous early years of the Cold War, when engineers and military planners were willing to try almost anything to gain an edge. The project combined serious scientific ambition with a dash of the fantastical. While it failed to produce the combat-ready UFO that its creators envisioned, it demonstrated remarkable creativity and daring. The lessons learned from it, in both what worked and what didn't, fed into later successes in VTOL aircraft and advanced flight control. And the sight of the gleaming Avrocar on display serves as a tangible reminder that no idea, however extraordinary, is beyond exploring. Project 1794 remains a testament to the spirit of innovation, an era when American and Canadian engineers dared to chase a dream as wild as a flying saucer, and in doing so, expanded the frontiers of aeronautics, even if they fell short of the stars.